Welcome, boys and girls, to another edition of Burbank High Chemistry Labs. Okay, and this is going to be one of the first of two stoichiometry labs that we're going to do. And again, normally you guys would do this in class with your partner, but that's not the case this year. So here we go. All right, so we're going to do this reaction here. We're going to take a solid piece of magnesium. You can see it right there. And we're going to add HCl to it, which is hydrochloric acid. The hydrochloric acid is dissolved in water, so it's not pure hydrochloric acid. Okay? And a single replacement reaction is going to happen, right? Magnesium is going to replace the hydrogen to make MgCl2, which will also be dissolved in the water. And the hydrogen will be replaced and will cause hydrogen gas, which you will see escaping out of the beaker, right? There will be a lot of bubbling, which confirms the presence of a gas, hydrogen gas. Okay? Now, I'm just going to tell you ahead of time that magnesium is the limiting reactant, so you will see this get all used up. And the excess reactant will be obviously the hydrochloric acid. You'll see that there will be a lot left over. Okay, so our goal, we can't do much about the hydrogen gas. It's going to escape into the air and it's gone. Our goal is to collect this guy right here. But we want to collect it without the water. So we're going to, after the reaction's over, we're going to boil off the water and excess hydrochloric acid, and we will get this white powder called magnesium chloride solid. Okay, so, and then we're going to weigh the magnesium chloride that we recover, and we will compare it to the theoretical value that you'll calculate with your teacher. Okay, all right, so here we go. So the first step, here's the lab handout. You want to zoom in there. Okay, thank you, Mr. Iwan. All right, so the first thing we're going to do is measure out the length of our magnesium metal. We're not going to weigh it because you'll see you get a better precision. So I'm just going to do this, all right? Measure out the length.
Hold on.
Oh, okay. Take two.
Take two, okay.
All right, so the first thing we're going to do is measure out the length of your magnesium metal. So I'm measuring it in centimeters. Now remember, each line is 1/10 of a centimeter, so we got to estimate to the hundredths. And I would say that's about 15.57. That would be my estimation. It's somewhere in between the 15.5 and 15.6. So I'm going to say 15.57. That's my, so I'm going to write it down. Okay. Now, okay, so we've taken care of that. I'm going to put that aside for a moment. What is number 2 here? Well, I had my TA last year measure a whole meter's length of this magnesium ribbon. And a meter of this magnesium ribbon, and my TA wrote it down right here, is 1.861 grams per meter. So a meter's length of this magnesium here is 1.861 grams. That's all right. My TA measured a meter of this magnesium ribbon. You can see it right there. And my TA wrote down 1.861 grams. So now, if you look here, we know, and this would be for every group, that the magnesium is 1.861 grams per meter. So we're going to use that to figure out the grams of your magnesium strip later on. All right, so my magnesium strip was 15.57 centimeters. The magnesium metal is 1.861 grams per meter. All right, so now the next step is to measure out approximately 10 milliliters of 3.0 molar HCl. Now you guys don't know yet what the 3.0 molar means, but it's a measure of how strong or concentrated, I should say, the acid is. And we'll learn that second semester. But okay, as long as I have between 8 and 10 milliliters, I know that I have plenty of acid. So here's what I'm going to do. I'm going to take that, and I'm going to measure out my acid. I got my goggles on. I'm going to measure out between 8 and 10. Okay. All right, now what do you notice about acid, boys and girls? It looks just like water, right? So you don't want to go into a chem lab and go, oh cool, I want to drink this. You'd be like, ah. Okay, or touch it. All right, so I poured out, I poured between, it's hard to see, you can probably see better with the camera, but that looks like it's what, maybe 9.4 something? Am I looking at that right?
Yeah, about 9.4.
These are hard to read. Yeah, each line on this graduated cylinder is 0.2. So it looks like 9 and 2 lines. So I'm going to say 9.40. All right. Estimate to the hundredths place. So I'm going to write 9 point. Can't write backwards. 40. All right. All right. So now the last thing we need to measure before we start is the clean 250 milliliter beaker. We got it right here. I'm just going to put it on the scale here. Do the old zero out thing. One more time.
Okay, sorry.
All right, so that's okay. We're weighing this. We weighed the empty beaker, and it's 132.81 grams. So I'm gonna put 132.81. Okay. All right. So now we have all our measurements before we start the reaction. Right there. There they are. Excuse me. All right, so now we're simply going to follow step 5, which says put the HCl and the magnesium in the beaker so that they react. Okay, so take the beak, you can fold up the magnesium strip, put it in there, and watch what happens when we pour the HCl over it. Let's get a white piece of paper. Do you have any printer paper?
Yes, I do.
We're putting the beaker on a white piece of paper so you can see the reaction better. All right, so here we go. I'm going to pour the acid over the magnesium. And watch what happens. Look at that. Look at that. Okay, you can see the acid is, right? This is the single replacement reaction that's happening. The smoke, the bubbling confirms, and the smell confirms that hydrogen gas is coming out of the container. And now we just gotta wait maybe about 20 more seconds. Whew. Just wait for everything to calm down, so all that fizzing and bubbling. All right. So it looks like it's pretty much calmed down. Let's double check. All right, so no more, and you can see it's very clear. All right, so the reaction's done. There's no more fizzing and there's no more changing. Now, what's in here? Okay, so now, boys and girls, we have, looks like clear water, but the hydrogen gas is gone. The magnesium has been all used up. So what is in here? All right, we got magnesium chloride swimming around in here with water and some excess acid. Okay, so what we're going to do next is we're going to boil off the water and excess acid, and then you will see the magnesium chloride solid magically appear. Okay, so let's do that. We'll put it up on the Bunsen burner. Set that up. There we go. All right, so it's just going to take a few minutes. I don't know if you want to leave it on or just come back in a minute or two. It's up to you, Mr. Island.
Maybe I'll leave it on.
Yeah, just let them, they can always fast forward through this. All right, so you can see that the water and the excess acid is boiling out of there. So I'm going to stand back because I don't really want to breathe in excess acid. Normally, when we have students do this and there's 10 of these going on in the classroom, we make sure to have the windows open and I got the fans going. And this is why you always wear your goggles.
Now it's focused. Just
Okay.
gonna have it sit on it.
All right. And
Oh, look at that.
okay, so now you guys can see the magnesium chloride is appearing because most of the water and acid is boiled off, and you can see magnesium chloride is a white powder. All right, so that should be good enough, so I'm going to turn off the heat. All right. Okay. And we're going to wait for it to cool down a little bit. And we also want to make sure that any water or acid, extra acid, gets out of there. So we're going to let it boil off. Okay. Okay, so I'm gonna grab it with my Mickey Mouse glove here. Hello, boys and girls. And we're gonna set it on the table, let it cool down for a few minutes. All right, and while that's cooling down, okay. See that? That's the magnesium chloride. Okay, and then all we gotta do is weigh the beaker and the magnesium chloride. So we just gotta weigh this, but I'm gonna wait until I can grab it with my hands. And then that's the lab, and then in class, your teacher will do the calculations with you. All right, so we'll just wait until we weigh it. And as long as this weighs more than the empty beaker, it's a success, right? As it should. Boys and girls. Okay, so it's calm, it's cooled down. All right, it's a little warm, but you can see the magnesium chloride in there. So we're gonna weigh it with the beaker. And it weighs 134.25, which is more than the empty beaker, so that is good. Okay, so you can see the beaker, 134.25 with the MgCl2 and then empty, so. All right, so that's the lab. That's all, folks, for this one. And stoichiometry lab number 2 is coming up next. So there you go.